Part 1 needed 2 loops. Part 2 needs 1. The difference is a single character, and a pattern you'll use across at least a dozen problems. Concatenation of Array. Part 2, the Modulo pattern. Same problem as Part 1, asked at Google, 4 times on record. Meta, Amazon, Adobe, OpenAI all on record too. Today's version is the elegant one, the one interviewers actually want to see. Quick refresher. Given an array of integers, build a new array twice as long, where the first half is a copy and the second half is another copy. Return that array. Same example as Part 1. Input 1, 4, 1, 2. Output is those 4 numbers, then those 4 numbers again. Constraints unchange. At least one element, at most 1,000. Values are small positive integers. No edge cases, no overflow risk. Pause for 10 seconds. Knowing it's one loop, can you guess the trick? 3, 2, 1. The trick has to do with the math. Specifically, remainders. Think of a record on a turntable. The needle moves forward continuously. But the song loops back to the start every revolution. Your loop counter is the needle. The remainder operation is what tells you where you are in the song. The whole algorithm, 4 boxes this time, not 5. Get the input length. Allocate the output. Run one loop, twice as long. Inside the loop, write to the current position. Read from the position modulo the input length. Return. Quick check. With an input of length 4, what's 7 modulo 4? 3. What's 6 modulo 4? 2. What's 4 modulo 4? 0. The remainder wraps. Setup is identical to Part 1. Allocate the output array with twice the input length. Locked, fixed size, ready to receive. Now the instinct. Instead of 2 loops, 1. Walk a counter from 0 up to twice the input length. For every position, write one element. The question is, which element from the input do we read? In pseudocode, get the length, call it n. Allocate output of size 2n. One loop, counter goes from 0 up to 2n. Body, output at counter equals input at counter modulo n. 3 lines total. JavaScript, same function signature as Part 1. Function get concatenation, takes one parameter, returns the new array. Same 2 setup lines. Store the input length in n. Allocate the output array of size 2 times n. Here's where Part 2 diverges. One loop. The counter runs from 0 up to 2 times n. Twice as many iterations as Part 1's first loop, but the body does both copies at once. The body. Output at counter equals input at counter modulo n. Read that twice. The counter goes 0, 1, 2, 3, 4, 5, 6, 7. The remainder goes 0, 1, 2, 3, 0, 1, 2, 3. Same input slots, twice. Why the remainder works. 3 lanes. Top. The counter, running 0 to 2n minus 1. Middle. What the remainder operation returns. Bottom. The input cell we read. The counter advances. The remainder wraps. The same 4 input cells get read, in order, twice. Trace it. Input 1, 4, 1, 2. Length is 4. Output starts as 8 blank slots. One loop, 8 iterations. Counter 0. Remainder 0. Output 0 is input 0, which is 1. Counter 1. Remainder 1. Output 1 is input 1, 4. Counter 2. Output 2 is 1. Counter 3. Output 3 is 2. First half filled. Counter 4. Remainder is 4 modulo 4, 0. Output 4 is input 0, back to 1. Counter 5. Remainder 1. Output 5 is 4. Counter 6. Remainder 2. Output 6 is 1. Counter 7. Remainder 3. Output 7 is 2. The remainder wrapped us back to the start. Final result. 1, 4, 1, 2, 1, 4, 1, 2. Identical to Part 1. One loop instead of 2. The algorithm is correct. Time complexity. One loop, 2n iterations. We drop the constant, big O of n, same as Part 1. Linear time. Space complexity. Same output size, same auxiliary needs. Big O of 1 auxiliary. Big O of n total. Identical to Part 1. Trap 1. JavaScript specific. The remainder operator with negative numbers is weird. -1 modulo 4 is -1, not 3. You won't hit it here because the counter starts at 0. But remember it for problems with signed indices, like rotations. Trap 2. Forgetting the remainder. If you write output at counter equals input at counter, without the modulo, you index past the end of the input on the second half. JavaScript returns undefined, silently. The output ends up with undefined values. Same bug shape as part 1, different cause. Remember the turntable. The needle never stops. The song restarts every revolution. The remainder is what tells the turntable where in the song to play. That's all you're doing here, using the counter's remainder to wrap back to the start of the input. Part 1 versus part 2. Same complexity. 2 loops versus 1. Offset shift versus remainder wrap. The remainder version wins 3 ways. Cleaner code, better cache locality, 1 sequential pass. And the pattern reuses across array rotations, ring buffers, hash table probing. 4 problems for the price of 1. Recap. 1. Allocate the output of size 2n. 2. 1 loop, counter 0 up to 2n. 3. Output at counter equals input at counter modulo n. 4. Same O of n time, O of 1 auxiliary. 5. Remember the modulo wrap pattern. You'll use it again. The Concatenation of Array series is complete. Drop the next coding problem you want me to crack in the comments. Top voted goes next week. Subscribe so you don't miss it.